Hey guys, welcome to the 14th tutorial of data structures, and in this tutorial we are going to see the linked list implementation concept of stack ADT in linear data structures. And last video we have seen how to implement the same concept in array implementation, and in this tutorial we are going to see how to implement it in a linked list implementation concept. Okay, so in this linked list concept, the main thing we are going to implement is a node concept. Okay, so what is a node? A node is a single segment which consists of two segments, where the first segment consists of the value itself and the second segment consists of the address of the next node. So in this linked list concept, what we are going to see is we are going to see the concepts of nodes and how it acts and how it is being implemented in linked list concept of stack ADT. Okay, now this stack ADT, it is a linear data structure where it follows the first in last out or last in first out concept. Right, now let's take an example and let's implement the linked list concept in stack ADT with the real time stack itself. Okay, so let's assume we will create a stack. This is our stack. Okay, and this is a sample node, and the operations for us are push 30, 40 and 50, then pop 1, 2, then push 60, pop 3, 4. So these are the operations which we are going to do so far. Okay, and let's assume the size of stack is 5. Okay, now the first operation which we are going to do is push operation. So the first element we have to insert is 30. So we are going to insert an element 30 into the stack, so which is push operation. We are inserting an element into the data structure of stack ADT. So before inserting the element, the value of top would be -1. So after inserting the element, the value of 30 would be, top would be 0. Okay, so at this stage 1, top is equal to 0. Okay, now we are inserting the next value, push 40. So we are going to insert a value 40. So top is equal to top plus 1. The value gets increased, and in second step, top is equal to plus 1. The second step is over. Now pushing the third value in, 50. So we are inserting the third value. So top again goes up. So top is equal to top plus 1, which is plus 2. So top is here so far. Okay, so all three operations are done. Now what we are going to do is we have to pop 1 and 2, which means we have to do the pop operation 2 times. Okay, so pop is nothing but deleting the element from a stack. Now which element should we delete? So we have to delete the element which has been inserted at the last. So the last inserted element is 50. So the first element to be removed is the last element inserted. So last in, first out, which is pop operation. So again, for fourth step, top is equal to top minus 1. So from plus 2 it becomes plus 1. So top goes back to this place. Now top is available at here. Okay, now again the first operation is done. Now we are going to delete the second operation. Okay, second element. So now the last element inserted was 40. So we are going to do the deletion process, where we are going to remove the last element at the top. Okay, so again the top is being decreased to the next position. So now top is equal to 0. So 0 indicates the first place. Okay, so 0, 1, 2, 1, 2, 3, 4 and 5. So this is the size of the stack. Okay. Now after deleting the second element, top is at the first element 0. Okay. Now next operation. So far we have completed 5 operations. Okay. Next operation is push 60. So we are going to insert another value into the stack. So which becomes 60. Okay, and obviously top is equal to top plus 1. So top goes over here. So again, sixth operation, pushing 60 into the stack. So top is equal to plus 1. Okay, so for push operation you can see that from minus 1 it has changed to plus 1, plus 1, plus 1, 3 operation. And again for deleting we have decreased to minus 1, minus 1. And again for push operation we have inserted plus 1. Okay, so far we have 2 elements in our stack. Okay, now next operation, again pop third time and pop fourth time. So now we have to delete 2 elements in this pop process. Okay, so we are going to delete the last inserted element and then the element 30. So after these 2 processes, what happens is, in 7th case, top becomes 0 and 8th statement, top becomes minus 1. So we know that top is equal to minus 1 when the stack is empty. So now the stack is empty and top is back to minus 1. So top is equal to minus 1 indicates that the stack is empty. Okay. Now in this process, how are we going to perform the operation of stack ADT in a linked list implementation? The concept is very simple. So in linked list, it is a combination of several nodes. Okay. So in this several nodes, what we are going to do is, we are going to create a node. The node 1. Okay. So we are inserting the first element, element 30. So we are inserting the first element. So this becomes our top, and next element is null as we haven't inserted any other element. Okay. Now in next step we are going to insert 40. So what happens? Top is equal to top plus 1, right? So what happens is 30. So the element top is equal to top plus 1. It becomes 40. And the next element comes over here. So first and this becomes our new top. Okay. And now we are going to insert the next element. So what happens again? So this is our 30, this is our 40, and this will be our new element 50. Okay. Now, so this is how we will insert the elements in a linked list implementation process of stack ADT. Okay. Now, next process we are going to pop the element. Now, in order to pop the element, what we are going to do is, we are going to decrease the size of the top or position of the top. Now, so far we know that after inserting the 3 elements, this is our new top. Okay, so we have 3 elements in our data structures. Now we are going to do the deletion process. So deletion process is very simple. Top is equal to top minus 1. So we have to neglect this element and move the top from this place to this place, which means top is equal to top's next value. Okay, the new top is equal to old top's next value, which becomes, after pop operation, it becomes 40 and 30. This is after first pop. So after popping the second element, what happens is, again this element goes down and it compacts to a single element called 30. So this is after 2 pop operations. So push operation is over, pop operation is over. Again we are going to push the value 60. So after pushing the element 60, top is equal to top plus 1. So this is the element so far. We are going to push this element. So we are pushing a new element called as 60. So top is equal to top plus 1. So this is our new top. Okay. Now, so this operation is also over. And finally, we are going to pop the elements. So we are now going to delete two elements, where the first element 30 is being deleted. So top moves from tops to next place. Okay. So this becomes so after deleting 60 as an element, we will be having 30 alone. Okay. So this will be our new top so far. Okay. And after last deletion process, we will be removing 30 also. So top is equal to top minus 1, which indicates that top is equal to top's next value. Here the next value of top is null. Right. So top's next value is null. So what happens is top is equal to null, or top is equal to minus 1, which indicates that stack is empty. So this result only we have attained so far. Okay. So the same result we are having in linked list implementation concept also. So this is how we will be inserting an element or deleting an element, like push and pop operation, and we have seen that how top changes by inserting a value and deleting a value so far, right? So this is linked list implementation concept of stack ADT, and in next tutorial we will be seeing the applications of stack ADT, and let's discuss the applications one by one. Okay. So until we meet in the next tutorial, it's Karthikeyan signing off.